All right, so we're talking about lesson 20, and we're talking about probability of a compound event. We're not going to go through the entire lesson, but we're going to get set up with the understanding of what a compound event is. A compound event is really when two or more things happen. So, for example, down at the bottom, spinning this spinner with the purple and the orange, and then spinning this spinner with the 1, 2, and 3. So what's the probability of, let's say, spinning an orange and a 3? Well, one event after the other, okay? So we're going to put that into practice. I'm going to show you a couple of shortcuts and skills to really make sense of how to calculate probability. So we're going to skip ahead to page 199. So we're going to look at pages 199 through 201. Okay, so looking here, we're talking about, this is that work together piece. I think what I'm going to do is I'm going to walk you through it, exactly how we got the answers. So it says, work together, use a tree diagram to show sample space. This is the sample space, okay? So the outcomes are the sample space. When you see sample space, think outcome. So again, the first column shows the outcomes for spinner 1. Spinner 1. These are the possible outcomes. Why are these the possible outcomes for spinner 1? Because these are all the possibilities for spinner 1. So this is event 1. Event 1 happens on spinner 1. Event 2. This is all event 2 right here. So spinner 1 is E1 and spinner 2 is E2. And I'll erase that just to be clear. So thinking about these two different events. So why are there two branches to this tree? Because there are only two options here. Let me run you through it. In event 1, if we spin this spinner, we could get either brass, percussion, or woodwind. If we got brass, moving on to event 2, we could either get solo or duet. So there's only two possible outcomes in that second spinner or that second event. If you spun percussion, how many possible events are there on that second event, or possible outcomes rather? There are two, solo and duet. If you spun woodwind on the first event, how many possible outcomes are there for the second event? 2, solo and duet. And we record that as the sample space. So for event 1, first spin, event 2, first spin, we could spin brass and solo. Brass, solo. We could also spin brass, duet. Brass, duet. If we spun percussion, we could spin percussion, solo. Percussion solo, or percussion duet. Percussion duet. This last group, woodwind, we could spin woodwind solo, woodwind solo, woodwind duet, woodwind duet. So it's really a place for us to record all the possible combinations, okay? And this will make sense in a few minutes. Moving down, we're not going to do part A. No, you know what? We'll do part A. So it says, use a tree diagram to determine probability. What is the probability of flipping 1 heads and 1 tails in any order? Use a tree diagram to show your sample space. Again, this is our tree diagram. These are our branches. Sample space, we should be thinking outcome. Find the number of favorable outcomes. Okay. Write the probability. Number of favorable outcomes. Well, what do we want? What is the probability of flipping 1 heads and 1 tails in any order? So the probability of flipping, we want 1 heads and 1 tails. Heads, tails, tails, heads. So I'm going to write down the sample space. Heads, heads. It could be heads, and it could be heads. It could be heads and it could be tails. Heads or tails. It could be tails or heads. Tails or heads. Tails or tails. So, number of favorable outcomes. Remember, the favorable outcomes are flipping 1 heads and 1 tails in any order. Is this a heads and a tails? No. Is this a heads and a tails? Yes. That's 1. Is this a heads and a tails? Well, it's a tails and a heads, and it doesn't matter which order, so that's 2, and a tails and a tails. Not what we want. So, favorable outcomes, we could flip heads and tails in any order twice. Out of how many possibilities? 1 possibility, 2, 3, 4. So it's 2 out of 4. So possibility, or the probability rather, of heads and tails in any order, 2 over 4. And 2 over 4 can be simplified into, if I divide 2 and 4 by the same number, I'm going to divide them both by 2, divide by 2. 2 divided by 2 is 1, 4 divided by 2 is 2. The probability is 1/2. So P, probability of heads and tails in any order, is 1/2. So this is going to be the last example I walk through, and I'm going to leave you to do 4 and as much as you can on the next page by yourself, but let's look at it. Solve. First of all, check out the art. What are they asking us to do? I can use a tree diagram, a table of outcomes, or the probability formula to solve. And the probability formula was what I showed you with when we multiply those probabilities. So let's look at this. What is the probability of being on the green soccer team? Being on the green soccer team. Let's use that formula. I want to be on the soccer team, and I want to be on the green team. Let's start with the first event. What's the probability that if I spin this, I'm going to be on the soccer team? Well, I have 1 desired outcome, it's the soccer team, but I have 2 possible outcomes. So the probability that I get soccer is 1 out of 2. Well, what about the green team? Green. Are there any other greens here? No. So the desired outcome is green, and there's only 1 green. How many possible outcomes are there? How many possibilities are there? 1, 2, 3, 4, 5. 5. So it's 1 out of 5. And what do I do with these 2 probabilities, these 2 ratios? I'm going to multiply them. What's 1 times 1? 1. What's 2 times 5? 10. What's the probability that I'm going to be on the green soccer team? 1 out of 10. 1 out of 10. Or probability of green soccer team is 1 out of 10. And that's how we would write probability. What is the probability of rolling a cube numbered 1 through 6 twice and getting 1 each time? You try this one on your own. Determine how many events there are. Determine the probability of each event happening. Remember the desired over the possible. And multiply them. Alright, let's see what you can do. And then when you're done, do the bottom of this page. I hope this was helpful. So let's do the actual practice. Make a tree diagram to show the sample space. Alright, it starts us off. First thing I'd ask is identify how many different events are happening. Spinner 1, we'll call that E1, event 1. Spinner 2, we're going to call that E2 for event 2. Alright, now look at spinner 1. How many possibilities are in spinner 1? 2. How many possibilities in 2? 1, 2, 3. All right, so I know I'm dealing with an event that has 2 possibilities and a second one that has 3. Event 1, we're going to start here. Spinner 1 has how many possibilities? Football and soccer. I'm going to put an F and an S. Football, soccer. Now, if I spin football and I move on to my second event, I can either pass, kick, or block. So I could either pass, kick, or block. What about if I spun soccer? Do you think the possible outcomes could change? Or do you think they're going to be pass, kick, and block? If you said they're going to stay the same, you were 100% right. So if I spin soccer, I can also spin pass, kick, and block. So now let's look at our sample space. If I spin football, I could also spin pass, F, P. I could spin football and kick, F, K. I could spin football and block, F, B. I could, if I spun soccer, it would be soccer, pass, S, P. If I spun soccer, it could be soccer, kick. If I spun soccer, it could be soccer and block. These are all the different combinations that I could spin in this compound event. How many different outcomes are there? 1, 2, 3, 4, 5, 6. There are 6 outcomes. That's it, 6 outcomes. And that's all we had to do was find the number of outcomes. Another interesting way to do that is multiplying probabilities. And this is the shortcut that I mentioned before, and it cuts down on the work. This is a good way for you to understand where the numbers come from. But watch this. What's the probability of spinning either one of these? Let's say I wanted football. What's the probability of spinning football? 1/2. And what's the probability of spinning, let's say, pass? 1 out of 1, 2, 3. What I do with these ratios is I multiply them. 1 times 1 is 1. 2 times 3 is 6. This is always going to be the possible outcomes. I had 6 possible outcomes. 6 possible outcomes. Hold on to that for later practice. So let's look at that second example. I'm going to scroll the page up and let's explore. Remember, we want to identify how many events are happening. Toss a number cube numbered 1 through 6, and then, without looking, pick a square or a triangle from these 2 cards. So the first thing we're going to do is we're going to toss a number cube. And then we're going to pick a card. So how many events are there? 2 events. I'm going to just kind of diagram this there. And this helps us think through what's going on. Here's my number cube, and it's numbered 1 through 6. 1, 2, 1, 2, 3. And on the back is 4. On this side is 5. And on the bottom is going to be 6. So that's E1. Now E2 is going to be picking a card, either a triangle or a square. Okay? So, in E1, how many possibilities are there? Number cube numbered 1 through 6. How many possibilities are there? If you're saying 6, you're right. I'm going to draw how many branches? 6. 1, 2, 3, 4, 5, 6. All right? Now, on each branch, let's say that's a 1, that's a 2, that's a 3, 4, 5, and 6. Off of each branch, this is event 1. Moving to event 2, what are my possibilities? How many different outcomes could I have? 1, 2. That's how many branches I'll draw. Branch 1, branch 2. Branch 1, branch 2. 1, 2, 1, 2. 1, 2, 1, 2. Now, on each of these branches, I am going to move this up a little bit. There we go. On each of these branches, I could either pick a square or a triangle. And I'm going to actually represent that with a letter so that I can fill in my sample space a little more effectively. So square or triangle. If I rolled a 2, I could then pick a square or triangle. Square or triangle. If I rolled a 3, I could pick a square or triangle in that second event. And so on and so forth for the rest of these numbers. Square and triangle, square and triangle, square and triangle. So, from our last example, we used this outer edge of our tree to determine how many possible outcomes there are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12 possible outcomes. If I rolled the 6, I could also roll a 6 and a triangle and pick a triangle. If I rolled the 6, I could also pick a square. And I think you get the picture. All those different combinations of how that could work. Let me just run through real quickly what the sample space would look like. It would be 1 S, because I could pick 1 in a square. It could be 1 T, because I could pick 1 or roll 1 and pick a triangle. It could be 2 S, because I could roll a 2 and pick a square. It could be 2 T, because I could roll a 2 and pick a triangle, and so on and so forth. Again, I think you get the picture. We would just continue 3S, 3T, 4S, 4T, all in our sample space. That's all we had to do. Let's look at that skill or that strategy I showed you above to check our work. So let's say the probability of choosing a 1, or rolling a 1 rather, on this cube is 1 out of 6, because there are 6 possibilities. 1/6, and I'm going to multiply that by, what's the probability of choosing one of these? Well, it's 1 out of 2. 1 times 1 equals 1. 6 times 2 equals 12. The denominator is always the possible outcomes, and we've checked our work and we are correct.